I'm Corey Hulse. I'm part of Feromone Robotics, and we are a swarm-based robotics team. Swarm is when a group of individuals work as a team together instead of individually. They collectively share information amongst each other so that everyone can make informed decisions about what's going on everywhere. And before each individual person does any role, any task, they check the info that everybody else is giving them. Our inspiration for our models comes from eusocial insects, which are in nature considered the highest level of organization of any societies, even higher than humans. These models, based off their organization, have passed like every biological optimization model that's been thrown at them from biologists for years. For decades they've been trying to stump them. Our swarm concept, to put it into robotics, we want to use the methods of adaptation, self-learning, and organization to create a group of robots that can respond to any sort of task and environment that's thrown at them in the most efficient manner. And each robot will find the best part that it can do to benefit the group as a whole. We want them to be able to assist and conduct search and rescue operations after natural disasters, using these models as the most efficient way to go about it. We want teams for ground, air, and aquatic environments so that no matter the type of disaster, from tsunamis to earthquakes, they'll be able to adapt and learn how to handle these situations. Why swarm? Well, we believe that it would be really beneficial for these type of applications because 9/11 was a really big one that a lot of people know of. 1 in 6 casualties were rescue workers, which is a huge rate of fatality for people in these types of jobs. I mean, the mortality rate is really high, and these are trained professionals going in here. Our robots, they're robots instead of people. So if one of them goes down the line of duty, we have a couple hundred, if not thousands more to replace them. They're far more replaceable than a human being's life. They're smaller, so they can fit inside of smaller areas to disturb less of the structural integrity, which was a big reason a lot of people lives were lost. Because going into those really unstable places, you don't know, one wrong step and the whole thing comes crashing down on you. The smaller, lighter they are, the less chance that'll happen. Since they have a collective knowledge, they know the best ways to go about it, more efficient ways to search, so they can go down more safer areas, go to areas of higher concentration of people, to less time in the field is less risk. So if they know about everything going on, they can make better informed decisions. And the robots can work independently or with humans. So some applications you won't even need humans to be risking themselves in the field. The primary role we have them doing right now is keeping the workers informed and in contact with one another. And we have quadcopters that will follow the workers around and actually act as relay signals, because we got a lot of feedback from people in the field saying a really big thing that cuts down on time is that they're out of radio contact a lot. We have quadcopters that can follow you around, and when you do radio signals, relay them. And since they work with each other, they're a swarm. If you're going outside even of their relay range, another robot will come and double the relay range. They'll work as a network, making sure all the workers can keep each other informed. And so if you find somebody, a survivor or a group of survivors outside of radio range, you won't have to waste time walking all the way back to base camp or into radio range to let them know. You can immediately let someone know and get people out there as fast as possible. They can also be manually controlled remotely and get into tight spots. That way you don't need to disturb structural integrity, which risks the lives of not only the workers, but the survivors within the building. They have a load of sensors on them that can test for environmental dangers like air quality, high temperature, toxic chemicals. So workers always know whether or not they need certain safety equipment for themselves and survivors they're rescuing in that environment. A lot of people wonder, won't these robots get in the way? That's a big fear of a lot of rescue workers, was we don't want them to get in the way. We're trying to do this as fast as possible. We don't have time to set them up. We don't have time to lug these heavy robots around. That's not a problem with ours. On the right, you can see some of our robots. For example, the one on top is one of our first ground models, and it's smaller than a piece of paper. On the bottom is another quadcopter that we're using. It's one of our early stages of the ones that follow you around. We didn't design it, but we're currently making our own custom version that's even tinier because we want to get them able to fit inside of your pocket. So when they're loading up on their gear, there's no extra steps. It can integrate as seamlessly as possible, and they can just put on their coat. It's already in the pocket, and they can just throw it out there, and it'll follow them ready to go. And that'll be up pretty soon. All the data is broadcasted online over Bluetooth. There's no fancy computer hookups you need to do. You can just tell them what site you'd like to broadcast. You can choose that or not, even Bluetooth. So if you have a smartphone on you, which a lot of rescuers do for GPS and such, you can hook up to a robot. There's some Bluetooth sensors that work up to 300 feet. You can hook up to one and be like, what are the sensor readings for this area? Am I in a toxic environment? The market opportunity is a global market. Any country that's hit by natural disasters has a reason to have these. There's 33 countries in the world, developed nations, that have budgets reserved for search and rescue operations and branches within their government. Most local law enforcements in all of the cities in those countries have their own local search and rescue branches. And there's a huge private sector. Doing market research in Mesa alone, we learned this. There's numerous search and rescue operations in one city alone. And all of these are looking to cut down on time and do an efficient way to save lives. And we believe that we can help that. $60 million were spent by Australia on just one search for the Malaysia airline. That's one country on one search. And there's dozens of disasters, if not hundreds of disasters every year. And that's just one country on one search. So there's a huge budget opportunity for these. The competitive analysis, if you want to buy drones that you have to manually fly and that can only really take pictures or do videos, it's $300 to $800 for one drone. They don't really have that many autonomous features. The sensor capabilities, there's almost none on most of them. It's just the camera. That's basically all you get, $300 to $800 for one that can fly in a storm with a camera. And someone needs to be piloting it all the time. Our drones are way cheaper. We're trying to get them to fit in your pocket alone, so you don't need to do any fancy hookups, any fancy controllers or training or anything. They fly autonomously following you around as long as you wear a little chip on like a bracelet or into your coat already. It could be sewn in really easy like that. It'd be nothing. They have a multitude of sensors to tell you all these toxic environments, what kind of conditions you're in, anything like that. And they can be easily accessible when you want them. They're not blaring at you in your face. You can access them when you need them or when you want them. For ground-based robots, they can sell from $150 to $300. They don't work autonomously usually. Some do, but they're independent, they're slow, they're clunky, and they're pretty big and heavy, so they don't really cancel out the risk factor of disturbing structural integrity. And they don't work in swarm-like behavior. Ours do and collectively share information. So when they do work autonomously, they know everything that's going on, where they're needed most, and they can actually be recruited by other robots to come in areas of high concentration. So if they know there's a schoolyard, one robot will tell, hey, I found this schoolyard, and the robots nearby will know that's a place I need to search. That's a place with potentially a lot of survivors. And they don't necessarily need human control, and you can switch between that if you wanted to, though. The business model, we've spoken with a lot of search and rescue operations, and the feedback has been fantastic. Most of the reviews, when we asked scale 1 to 5, how much will this revolutionize search and rescue for you? It was 5 out of 5, almost every time. They're looking for something like this. They're looking for a revolution like this that can help them save lives and not risk their own lives in the process. Because that's the goal in the end. Is to cut down on time, cut down on cost, cut down on risk, the whole thing. Our robots are cheaper, far more useful with their range of sensors and autonomous functions, and they're non-invasive into the organization's strategies, so they would integrate right into the operations. And it's scalable on a global level because search and rescue organizations are tightly interconnected because there's joint searches conducted all the time, and sharing new techniques, new technology, it happens all the time between them. The team goes me, I'm the lead programmer and behavioral designer for the search algorithms. There's Miles, our lead electrical engineer, that is designing the whole wiring and sensors and electrical interface between the robots, and Alexander Opstead is our marketing and business operations researcher who talks to a lot of the search and rescue guys and gives us the feedback about that. And our roadmap is right now we're wiring up the quadcopters and testing them, getting them to be self-balancing and avoid any obstacles in the environment. And get them to follow you accurately through, say, doorways or tight areas. That way, you don't need to slow down for them. You can just keep going, and they'll always be at your back. We're getting the tabletop versions of our robots, small than a piece of paper, printed it up, and testing their full search and recruitment algorithms right now, trying to perfect that so they adapt as fast as possible to any new environment. And we're getting a new design ready to 3D print. We hope in the next 6 months. So like around next spring, to have the ground team and their algorithms fully tuned up to be able to adapt and to be able to integrate with any other swarm searching in the area seamlessly, so that if there's multiple search groups running these, they can actually coexist together and work well with each other. We hope to have the quadcopters fully able to go through any tough environments and to be able to relay those radio signals. and have our own design custom ones being printed at that time, so they can so we can fit the needs of any specific specifications that need to be met for any team talking to us. And we hope to have a vision system up to be able to recognize survivors immediately on our ground team much faster than other ways. So what we need to improve upon this is to get to the next stage of development, to really get these custom designs out there. We need a 3D printer that can speed up the production testing of new designs so we can faster evolve them. We need to buy some better hardware equipment for them so they make sure the computers run faster on board so they can have faster, more complex, and better informed decisions. We want some electrical development equipment like soldering irons, PCB mill boards to be able to more efficiently and have higher quality of the productions of our own custom electrical equipment. That way we can more specialize our robot-specific tasks. To increase our capabilities as a team and round out what we can do, we'd like to have new members join us. So we need referrals or anyone that thinks they can contribute to this team to just come up and ask us, and we'd be happy to take a look at what you can offer us. Having more contacts inside of the search and rescue operations game already, so that we can get a wider view of what we need to do to make them seamlessly integrate would be really fantastic, because that makes it just better for everybody, from us, from manufacturing, to the search and rescue, and the end users overall. The return on investment from all of these is that we're going to produce robots that redefine the search and rescue game and completely drastically cut down on the time it takes to rescue people, the risk involved, and the cost for these sorts of events. And it's going to lower the threat that natural disasters face as a society today.